All right, guys. Today we're going to talk about the one thing that scares away most people from AI engineering, the math. People think you need a PhD just to get started, and I'm here to tell you that's simply not true. Let's settle this right now. So, do you really need it? The short answer is no, at least not in the way you think. The idea that you need to be a math genius is probably the biggest myth in the entire field, and it's holding people back. The reality is, it's much more about intuition. You see, here's the great divide. The myth is you need to be wrestling with these dense PhD level proofs and memorizing 1,000 formulas, but in reality, what you actually need to be a great AI engineer is a feel for the core ideas. It's about building a visual intuition for what's happening under the hood and so you can power the code you write. And here's the best part. Almost all of modern AI just boils down to four core mathematical ideas. That's it, just four. And the best way to understand them is to stop thinking about them as formulas and to start seeing them as pictures. So let's do that. Okay, idea number one. Think of this as the absolute alphabet of AI vectors and matrices. This is how machines learn to perceive our world. To an AI, a word, an image, even a user's preference, it's not abstract, it's an arrow, a vector pointing to a specific location in a massive multidimensional space. And matrices? Well, they're the tools that grab those arrows and move them around, rotating, scaling, and transforming them to find new relationships. This is the language of data. You've probably heard the term embeddings, right? Well, this is all it is. It's a fancy word for turning concepts like words into these vector arrows. And every single time a neural network processes information, it's really just applying a matrix transformation, nudging all these points around in that space to find patterns. So if vectors are the language, our second big idea, gradients, is how model actually learns to speak it. This right here is where the learning magic happens. This is one of the most beautiful and powerful intuitions in all of tech. Just picture a ball rolling down a big curvy hill with the goal of finding the lowest possible point. In AI, that lowest point is the solution with the least error. The gradient is simply the slope of the hill. It tells the model which way is up. So to get smarter, what does the model do? Well, it just takes a small step in the opposite direction. It walks downhill. And when you do that over and over again, nudging millions of tiny parameters, that process is called propagation. It is the engine of modern machine learning. Okay, on to our third idea. This one's all about understanding that AI models are not all-knowing oracles. They have to deal with uncertainty just like we do, and this is a really key distinction. An AI doesn't say this is a cat. It says, based on everything I've seen, I'm 85% confident this is a cat. It operates in the world of confidence, not certainty. And that's what makes it so powerful and flexible. We actually use this idea to our advantage during training. There's a cool technique called DRO, where we just randomly ignore parts of the network. It forces the model to become less certain about any one piece of data, which makes it a much stronger, more generalized thinker in the long run. And that brings us to the fourth and final idea, and that ties everything together, which is optimization. This is the art of navigating that massive landscape of possible answers. And so remember that ball rolling down a single hill? Well, in reality, it's not just one hill. It's more like a massive mountain range with endless hills and valleys. Optimization is the grand strategy for navigating that entire landscape to find the absolute deepest valley, the best possible solution. So when you hear jargon like loss function, that's just the formula that defines the shape of this landscape and different optimizers. Now, those are just different strategies for exploring it. Think of it like adjusting the settings on your GPS to find the most efficient route to your destination. Okay, so we've got these four big ideas, these four pictures in our head. Now let's connect them directly to code you'll actually be writing. This is where it all clicks into place. Check this out. the whole concept of vectors that becomes the reality of word embeddings in your code, gradient descent. That ball rolling downhill, that is the magic that happens when you type loss dot backward. Probability. That's the theory behind your softmax functions and dropout layers and optimization. That's you choosing the atom optimizer. Every single one of these big ideas maps directly to a tool you will use. So you're probably wondering, okay, I get it, but how do I actually learn this stuff? Well, let's put it into perspective here. And the number one rule is this: learn the ideas, not the proofs. Seriously, if you take only one thing away today, let it be this. Focus on building that visual intuition, understanding the picture of what a gradient is doing, get a feel for a vector space. The formal proofs, you can leave those to the academics. The intuition is what you need to build amazing things. And here's a pro tip to make it all stick. The absolute best way is to combine learning with doing. Try to build a really simple model from scratch just using a library like NumPy. I promise you'll see the math and the code click together in a way that's totally unforgettable. So here's your ladder. First, just focus on getting comfortable with vectors and gradients. YouTube visual explainers are your best friend here. Once that feels great, move up a level and explore probability and optimization. Some stats will do you fine. Before you know it, you'll totally be ready to tackle these advanced online courses. MIT, Harvard, they have free ones, and start building real projects from scratch. So let's bring it all the way home here. I want you to completely reframe how you see and think about this. Math isn't just a gatekeeper trying to keep you out of AI. It's your superpower that you didn't even know you had, right? It's not something to fear. It's your personal toolkit here that's going to help you build amazing things. And when you grasp these core ideas, you'll understand why the code works, not just that it works, right? So that's what puts you ahead of the curve. And it's what's going to allow you to debug, to innovate, and to truly be a creator in this space. You now have the map. You know the 4 core territories of AI mathematics. So the only question left is, what are you going to build with it?